Okay.
Today I'm going to discuss two important rules in organic chemistry. Those rules are the Zaitsev product and the Hofman product. They allow you to predict how the products of a chemical reaction is going to go. Which orientation will it have? Okay. The first is the Zaitsev. The Zaitsev product and the Hofman product are rules when you determine an elimination reaction. What elimination reaction is two products have a reaction and they're on basic conditions. Under basic conditions, a base extracts a proton and forms a double bond or a pi bond, as we'll see later. And the Zaitsev rule says when two or more products are possible in a chemical reaction, the most highly substituted product will be the result. And the Hofman product says that the least substituted product will be the desired product. All right. Now for Zaitsev, say you have a chemical that looks like this. Okay? These are carbons. And to these carbons are hydrogens. These are hydrogens. This is bromine. Alright? And then say you have, this is going to be an elimination reaction. In elimination, you require a base. Our base is going to be sodium hydroxide. But ordinarily, we would just write, it's understood as this hydroxide. Okay. Now, what bases do, they extract protons. And we look and we see that Zaitsev rule says it's going to extract the one with the least amount of hydrogens, so it'll leave the most substituted product, because you would have this and this as your substitute. So what's going to happen is sodium hydroxide is going to deprotonate this carbon. Bromine is a halide. It's called a good leaving group. So this, and once this happens, it's going to take this proton, but these are represented electrons. These electrons move to this bond. But we have a problem. Because right here is another hydrogen. This carbon has 1, 2, 3, 4, 5. That's against the octet rule. The octet rule says you can only have 8 electrons in a valence. So what's going to happen is this bromine can suck these electrons and it leaves. This leaves our final product. This is our final product. This is the major product, or the Zaitsev. But also, the sodium hydroxide can take one of these. And then when that happens, it's going to abstract this. This is still going to be there. These electrons will move down, this bromine will leave. this would be your Hofman product. This is a minor product of this reaction. Okay, and a little bit about Zaitsev. He was a Russian scientist. He was a Russian chemist. He also studied with Markovnik. They studied under the same teacher, and they were kind of rivals. Okay, and then another example of this. Let's do a more complicated one. That's fine. Now, the Hofman product. This also works on elimination reactions. But this is different. When this is the Hofman product will form the least substituted product. You use this for it's something called bulky bases. These are bases which have large electron densities. They're big. They need room to spread out. They can't get in these tight spaces. So what they allow you to do, if this is your desired product, this one right here, you use a bulky base because they can only do this when they cannot form these. Examples of bulky bases are terabutyl oxide, lithium diisophylamine, and then triethylamine. These structures look like this. This is triethylamine, LDA, and terabutyl oxide. These are bulky bases. An example of a reaction with these is we'll take this same product. And we use terabutyl oxide. That's the least common one. Now, this is the structure. This structure has all these methyl groups bond to an oxygen. This oxygen wants a proton. So you could pick this one, or this one, or one of these. These methyl groups prevents it because they have electron orbitals. There's a lot of them. So they take up a lot of space. These bases need a lot of space to do their job. If it goes in here, it's not going to have a space because it'll be bumping up against these hydrogens. These three, it'll be bumping up against these, and all this. So it's just plus bromine has a big electron cloud, so it'll be bumping all these. The easiest one for this to take is one of these. Or it could also take one of these. We'll take this one. It'll take one of these, and you're left with. And this also causes the bromine to leave, so that'll be gone. You form your double bond. This is your product. Another example of the Hofman rule is a famous reaction called Hofman elimination. It uses a lot of methyl iodide with wet silver, and it produces only the Hofman product, it will not produce the Zaitsev product. An example of this would be, it's a way to make tertiary amines from quaternary amines, and I'll explain that. You have this one. This is a minor. This oxygen, the excess, is going to take these and then this right here, and you're left with this. You got the excess, so what's going to happen is these electrons will go over, and these electrons will take this. And you have an excess, so it'll keep going until these are filled up. These go away. You're left with this. Alright? But you still have some base around. So you have water act like a base. It's going to steal hydrogens. Alright, so we'll show it here. The water so that's a minus sign. The water will take this proton, the bond will go here. This will have too many and this will leave. So you'll be left. There's your product, like that. This will form a good leaving group, then you'll produce your amine. And hope this was helpful. Have a good day.